The airspeed indicator is one of the most important instruments in any aircraft. It shows how fast we are moving through the air, but speed alone isn't enough. Pilots use specific speeds, called V-speeds, for different phases of flight. Let's start by understanding the airspeed indicator before moving on to takeoff speeds and other critical V-speeds. The airspeed indicator has different colored arcs. The white arc represents the flap operating range. At the bottom of this arc is VS0, the stall speed with flaps fully extended. If you go below this, the aircraft will stall because it's not generating enough lift. At the top of the white arc is VFE, the maximum flap extension speed. Going faster with flaps out could damage them. The green arc is the normal operating range. At the bottom of this arc is VS1, the stall speed in clean configuration, meaning with flaps retracted. If you fly slower than this, the aircraft will stall. At the top of the green arc is VNO, the maximum normal operating speed. Beyond this, you enter the yellow arc, the caution range. You should only fly in this range in smooth air. The red line at the top marks VNE, the never exceed speed. Going faster than this could cause structural failure. Now let's move on to takeoff speeds. V1 is the takeoff decision speed. Before this speed, the pilot can abort the takeoff. After passing V1, the aircraft must take off, even if there's an issue. VR is the rotation speed, the point where the pilot lifts the nose for takeoff. Below this, there's not enough lift to fly. V2 is the takeoff safety speed, ensuring a safe climb if one engine fails in a multi-engine aircraft. After takeoff, climb speeds become important. They determine how efficiently an aircraft gains altitude after takeoff. VX is the best angle of climb. This means it allows the aircraft to gain the most altitude over the shortest horizontal distance. If there's a tree, a building, or terrain right after takeoff, you need to climb as steeply as possible to clear it. That's when you use VX. Since the nose is higher, the aircraft climbs more slowly, and airflow over the engine is reduced, which can cause overheating in some aircraft. VY is the best rate of climb. It allows the aircraft to gain the most altitude over the shortest amount of time. If there are no obstacles, VY is the best choice because it gets you to a safe altitude faster. The climb angle is shallower than VX, but the aircraft is climbing at a greater vertical speed. Here are some additional V-speeds that are important for flight operations. Let's go through them one by one. VA is the maximum speed at which full and abrupt control deflection can be applied without exceeding the aircraft's structural limits. It is also recommended for turbulent conditions to prevent excessive stress on the airframe. This speed decreases as the aircraft's weight decreases. VG is the speed that provides the maximum glide distance for a given altitude in case of an engine failure. Flying at this speed allows the aircraft to stay in the air for as long as possible while covering the greatest horizontal distance. VFR is the minimum speed at which flaps should be retracted after takeoff to avoid excessive drag and ensure stable climb performance. It is higher than V2 to maintain a sufficient safety margin. VLE is the highest speed at which an aircraft can fly with the landing gear extended without risking structural damage. VLO is the highest speed at which the landing gear can be safely extended or retracted. It is usually lower than VLE to prevent excessive aerodynamic forces on the gear system. VB is the speed that ensures structural safety during turbulence. At VB, the aircraft will stall before exceeding its design load limits when encountering strong gusts. These are just some of the many V-speeds used in aviation. Each aircraft type has its own specific values for these speeds, which are determined by the manufacturer and listed in the aircraft's flight manual. Knowing and understanding V-speeds is essential for safe and efficient flight operations. If you want to learn more about aviation concepts, stay tuned for more content.